Today we're going to be going over all the FRQs. So, yeah. Yep, today's FRQ time. So we're going to start in about a minute to let people join. So, until then, how are you guys feeling for the Precalc exam? You guys feeling confident? Not confident? Like, what are we feeling for the Precalc exam? Feeling in between? What's like the in between? Like, what's making it so you can't be at like a 10 or a 9? What's what's stopping this? What's preventing it? For Yes, 10 to max, 10 to max. Yeah, what's preventing it? Polar function just in the way. You have polar. I'll be recording it. It should go on the YouTube. Hopefully by before the exam. I'll be record. This one's recorded, and tomorrow's, but yesterday's and Monday's won't be. So we are gonna start now because it's 2:30. So let's get rolling. So welcome. Today we are going over FRQs. So let's get started. This is prepared by 5Hive and it's led by Lance. And we have a cool website that has lots of stuff for pre-calc, like a lot of stuff. So let me send the link real quick to the website. So you can there's lots of stuff, there's lots of articles on this website for pre-calc especially. And if you'd be interested in applying, the link is also in the chat if you're interested in applying. And we also have an Instagram and TikTok. And the disclaimer, AP is a trademark which registered by College Board, which is an affiliate with or does not endorse this resource, nor the 5Hive team. And expectations, don't do something that'll get you banned. So in other words, follow all server rules. Be kind to each other, and ask questions. There are no dumb questions, so always ask them. A mistake made now is a mistake you won't make again later or on test day. And lecture stats, if you attended, people who attended last year, 73% of them got a 5 and 90% got a 4 or above. And 98% passed. And that's pretty much it. So now we're going to go on with the FRQs. So these are all taken from the 2025 FRQs, which I won't do, so you guys can use them as practice. But I'll go over what they cover. So FRQ 1 covers something called function concepts. And it's mostly just function compositions. That's like plugging in a function to another function, inverse functions, zeros of the function, and limit n behavior. And then the other part is talking more about rates of change and stuff like that. FRQ2 is also pretty similar, but it's modeling a non-periodic context. So that means no trig. FRQ2 has no trig. And these are the calc ones. Yeah, FRQ1 and FRQ2 are the calculator ones. And for this question, this first part, you're calculating values and you use a regression for this. And then you have to, the first question is asking you just to plug in these numbers to make 3 equations. So you would say, for this, it's like a quadratic. So you would say 25 equals a 0 squared plus b 0 plus c. And that's the first one. And you just do that 3 times. And then you use a calculator to find these, or you can algebraically solve them if you choose to. And then the rest is mostly just about, is it appropriate model, do plugging in values, find rates of change, stuff like that. FRQ3 is the one that you've seen the most, which is probably the trig FRQ, which is you have some context and you have to find points for it. You have to make an equation that might be sine or cosine, and you better read it because depending on which one it is, you should always make sure. And then you have to look at rates of change. You could probably do these first two part. You could probably do C without doing it. So you could look at, it says between T1 and T2, and it says T coordinate of G and J. So you could describe these two. So you don't even need to do A and B to find C. And then finally, FRQ4 is your algebra, pretty much FRQ. Your first part is usually just sense solving. Your second part is manipulation, and your third part is usually solving again. And it involves exponentials, logs, trigs, and inverse trig equations. Any questions about any of these FRQs? About the 4 types of FRQs? And these are non-calc, yes. FRQ3 and FRQ4 are non-calc. Okay. Yeah. FRQ3 and 4 are non-calc. FRQ1 and 2 are calc. Can you leave them for this part? You have for FRQ2, you have to say what the variables are. So for like in the FRQ booklet, you have like lines. So you would say like A dot II, and you would say A equals something, B equals something, C equals something. For finding A and B, no, because you can use a calculator for this. So you don't have to show work. But for this first step, you need to write all your equations. For round to the third decimal or don't or truncate at 4. Those are the 2 options. Depends on how the rubric states the answer. Sometimes there's points for work, sometimes there isn't. It's recommended to show your work. So if there's no other questions, and then now we're gonna go into practice. For finding C in FRQ3, do we need to show work? No. For finding your C value, no, you don't have to show work. For this, the only points are given for each part. But if you need, you're gonna have to find the point. You're gonna have to show work. So just show the work in the booklet. I think for the ones where I assume not to show work, I probably just you could just say using technology or using the calculator. You could say that always. So if there's no other questions, now it's time for a poll. Which FRQ do you guys want to do first? I'm gonna put a poll. I'm gonna put a poll. I'm gonna put a poll. I'm gonna put a poll first because I'm not counting. See, I do a poll because the only reason I don't go in order, some people are more confident than others, so it would be a waste of time to do all of them. And I'll just keep doing a poll for each FRQ. And also, you get about 15 minutes per FRQ. But for the purposes of time, we're going to do 9 minutes per FRQ. So, wouldn't it be better to go in order? Some people don't need all. Most people, yes, some people say 1 is really easy, some like that. So the point is to do whichever ones are needed for people instead of, because we can only do so many in like 2 hours. So if we do the ones people need the most, that'll be the most beneficial. Okay, the one that's winning right now is FRQ3. So we'll do FRQ3 first. We'll just do the first. We'll just do it again. Alright, we're gonna do the first. We're gonna do this one first. I'll show each part one by one. What's one about? One's about like the function stuff. Get this on your quiz. Damn. So okay, if I zoom in, then you can't see the questions, the issue. Hold up. I'll send this in screenshots in the chat so then you can actually see it. Send this in like 4 screenshots. They're in the AP Precalc pins. The context. Part A and B. Part C. Alright. So I'm going to leave it on the context because the other parts are pretty repetitive. So I'm just going to leave it on the context so you guys can see. So I'm gonna give about 8 minutes for this, and in the meantime, I will answer questions while we wait. I try using it, whichever one you're gonna do. So maybe do it on paper if you plan to do it on paper and all that stuff. Oh, and for part B, the function is a cosine. So that's like if you, because I can't show all the parts at once. So you're gonna have space in the on test days. So let me pull up the booklet real quick. So this is what the FRQ booklet looks like on AP exam day. So you're gonna have to write your name and stuff like that, and AP ID label sheets. So your first question, you get all the space. I don't know how physics 1 looks like. I haven't taken physics 1. So you get all the space for each question. So like for part A, you get this entire page pretty much to do part A. Part B and C, you get like another page. And then go for question 4, you get like a page per section. So I'm gonna put back the context though. Okay, 7 more minutes left. Actually, I'll just go until 50 exactly. So 2:50 p.m. we will switch. We will go over the answers. 2:50. So 7 minutes. You don't have to type your answers in the chat if you don't want to, because it's a lot to type in the chat. So no, you're doing the entire FRQ. So that's why I sent all the stuff up here. You're gonna do all 3 parts. You're gonna do the points, formula, and talk about the rates of change. So is it concave up or is it concave down and all that stuff. I think for this one, is it positive, decreasing, and is the rate determine the concavity of the graph. And the graph is a cosine graph, but I can't really show it, so. Okay, I'm gonna zoom out now because people have seen the context enough, so now you should be able to see part A. Oh no, you can only gain points. You can't lose points. Oh, yeah, yeah, you can have negative points if you want. But I wouldn't recommend it because theoretically time isn't negative. So I would say keep it positive. But you can have negative time. It doesn't really just make sense. We'll go over it in 5 minutes. And I will also show the rubric to see how points are given as well. Yeah, I'm also just choosing random letters, so there's not like any pattern to the FRQs I'm choosing. Because like each FRQ has multiple parts, so we're just doing whichever one comes up first. So you get some people have done some of these, so I have to choose ones that you guys haven't done yet, hopefully. I have 4 minutes left. Diameter of 8 but 2 feet from the ceiling. I'm gonna go over that. That's like the I think most confusing part of this entire thing. All right, 3 minutes left. All right, 2 minutes left. Fine, last 2 minute warning. Last minute or around 30 seconds. I don't have a seconds timer, but yeah, there are infinitely many answers to most of these. Most of FRQ3 has multiple answers. FRQA has multiple answers. The C shift can have multiple answers. Alright, we're gonna go over it now. So, first part. It says 2 rotations. I'm gonna read the thing. It says out a diameter of 8 feet. That means we have a radius of 4 in each direction. So we're gonna use that, but not yet. So next, we're gonna get to completing 2 rotations every second. That pretty much means your frequency. If it says every second, that means it's your frequency. And frequency, which is F, is equal to 1 over your period, which I'm going to say T. So if we have a frequency of 2 is equal to 1 over T, your period is going to be equal to 0.5 or 1/2. It says, and you're looking, and this function models the distance between S and the ceiling. And it says at T equals 0, point S is located directly above the center of the hamster wheel, 2 feet away from the ceiling, which means that's your minimum point. That's your least value. So we're going to say this is point J is something, comma 2, because that's our least value. At our next point, we know we have to go, we're going to get a bit farther, right? So we know our maximum distance is 10, right? Because if we go 8 to the other side, that's 10. Which means now we know our y-coordinate of our maximum is 10. And then this is the midline, which has to be in between these two numbers. So now we have comma 6. Any questions until there? Why not 2 pi over period? Because frequency is, that's defined B, yeah. Frequency equals 1 over period, or period equals 1 over frequency. B is not your frequency, that's your B value. That's not your period. How to find frequency? Frequency is equal to 1 over period, or period is equal to 1 over frequency. You just flip your period. To find your minimum, it says at T equals 0, point S is located directly above the center of the hamster wheel, 2 feet away. And it says the distance between S and the ceiling. So that's your minimum distance, which means it has to be your bottom. You could say this is 0, but then you have negative time. So we want to avoid negative time, because what is negative time? So we're going to shift it 1 to the right to be positive. You can use fractions. So with that, now we know that this is 1/2 as well. Frequency is just how many times does it spin in a second. Or, yeah, how many times per second something happens. So how many waves in a second, instead of it takes this long for one wave. We're saying how many waves in a second. Wait, I'm going to hold up before we continue. Your frequency is 2, so you have to flip it to find your period. Or take the reciprocal of it, which is 1/2. No, your x value is going to change by 1 over pi. Unless it tells you your things changes by pi, you don't use pi. Pi and all that stuff comes in part B. Part A has nothing to do with pi. So now we know, okay, I'm going to zoom in this part. So now we know this is 1/2, right? And it says we complete a period every 0.5 seconds, which means we come back to the same starting position every half second, right? So if we were to extend this a bit to figure out what that would be, we know this would be 0, comma 2, because that's where we would start again. We would start at 0, comma 2, which means now we just have to find the exact middle of this. So between 0 and 1/2, That would be 1/4. Similarly, now we know this goes in terms of this from F to J is 1/4. So from J to P has to be another fourth. So we know P is 3/4. And then finally, to find G and K, you have to find the midpoint between 1/4 and 1/2, which is what's halfway between 1/4 and 1/2? 3/8, yeah. 3/8. And what's the halfway point between J and P? 5/8, yeah. Alright, now any questions about part A? And remember, these are possible coordinates. You could have a shift. You could have negative time. I wouldn't recommend negative time, but so this is part A. Any questions about part A? Alright, there's actually tons of people typing. It's alright. See. Oh, and the point distribution for this is if you got your t coordinates right, that's +1. And if you got your h of t right, that's another +1. Can you divide something by 4 to get increments of time? Yeah, if you divided this by 4, you would get 1/4. You would say this is 1/4, 2/4, 3/4, 3/4, 4/4, 5/4, 6/4. But I would think of it more of like what you have to get to each point. So like do it incrementally instead of memorizing something. Because when you memorize something, that's where you can make mistakes. Except in formulas when you have no choice. But if you think about it like logically and stuff like that, it's easier to keep it straight. And like if something comes up unexpected, it's easier to know. If it was 4 rotations in 4 seconds, well, you would divide first, so you would get 1 rotation per second. I haven't actually looked at your answer yet, but I'm just going one question at a time. Just a question, will I not be able to find C right away? Yeah, you could. We're gonna get there. Alright, so now part B is write the values of the constants. So now we're gonna start with our D value, because D is the easiest one always. It's just your midline, which is 6. So if you found 1 point, that's 1 right there. Next point. Our A value is equal to our amplitude. So that's like this vertical distance, which is 4. Midline is 6 because that's what that's like your equilibrium or your resting position. That's like the middle of your graph. Amplitude or A value is your distance from the middle to the top or from the middle to the bottom. Isn't A negative? It doesn't have to be. It depends on how you chose your values. So like I chose my values so my A wouldn't be negative. If you were to flip this and say like let's say put 2 on top, then yes, you'd have to make everything negative to compensate for that. So it depends on how you say your values. Then yeah, you could do that. You would just yeah, we're gonna get there. We're gonna get there. Alright, so now so if you got A and D right, that's +1 point. So now you're at 3 for like I think 8 points or something. I forget how many points are there. 3 for 6. 3 for 6 on this FRQ so far. So now we're gonna get to our B value or our period. So far we have h of t is equal to 4 cosine of b t plus c plus 10. So now we're going to try to find our b value. Our b value is equal, we know our period So our t value is equal to 2 pi over b, right? So now we know our period we said was 1/2. So 1/2, I'm going to say 0.5 for this. So 0.5 is equal to 2 pi over b. We're going to solve for b, which we get as b equals 2 pi divided by 0.5, which means b is equal to 4 pi. Yeah, d is 6. Oopsies, yeah, it's 6. Oopsies. It's 6. So b is 4 pi. Any questions about finding b? So now, okay, wait, you have a question about, oh wait, what's your question? Oh, okay, you don't have a question, okay. So now you found b. So now one way to solve it is, okay. Oh wait, you have a question, okay, hold up, I'll wait then. Okay, so if you want this, so it would be, I'm gonna scroll back up here because not much space, but let's say 2 pi over 1/2. You would do keep, change, flip. So you would do keep the top and flip. You would flip this into this, which would be 4 pi. So if you want to do, that would be, if you were to do keep, change, flip, is the way you do it. Do we get graph paper on exam? No. You just get the FRQ booklet, which I showed before. How do we get 1/2 for the b value? Okay, okay. Our next step is to find our c value. So there's two ways to think about this. I'm going to do this the conceptual way. Which, okay, so what does the cosine graph look like? Cosine starts at 0, 1. It starts at its maximum, yeah. So we know it starts at its maximum. So what's our maximum here? We have point F is our closest to the maximum, right? 1/4. So we know after we do our b value, we know it's 1/4. So we know it's going to be h of t equals 4 cosine of 4 pi t minus 1/4 plus 6. And that's it. Because your 1/4 means you shifted to the left to the 1/4. Now you're here, and now it's a cosine. Because remember, shifts are negative. Remember, if we want to go right, we have to do minus, and to go to the left, we add. It's like our HK. If we had like a quadratic, we would do x minus 2 squared to go to the right. Doesn't have to be. You could maybe go the other way, but it's probably negative. Yeah, they use the standard form is plus c. It's always negative. There's a question. Oh, hold up. Let me go question. Hold up. If a equals -4, c equals 0 is right. If a was equal to -4, that means this would be down here, and you would have to do a shift of 1/2. I'm pretty sure then, because if you were to do a equals -4, you would be at the bottom, and to get a cosine graph, you would have to have, now this would be up here, which means you have to shift 1/2 to get to the top. Oh, but your coordinate, I didn't, oh wait, hold up, let me look at your coordinates first. Yeah, I think that'd be right if you would do that. I'd have to graph it out to check, but I'm pretty sure that's right. We'll do another poll. Hold up. Hold up. Let me go step by step. How did we get C? You got C by looking at your graph. So you saw that you started at a maximum, right? A cosine starts at maximum. So you have to shift this to 0 because a cosine starts at 0 maximum, which means you have to shift to the left 1/4 to get your starting value to be at a 0. Another way you could do this is you could just plug in a point and solve. So you could say h of like 3 over 8, or no, 2 over, h of 1/4 equals 4 cosine. You could solve for c if you want to. That's like the algebraic way of doing it. When your amplitude have to be negative, you don't. It never has to be negative unless you want to swap it. So unless you want to flip it to the bottom and stuff like that, it doesn't. It never has to be negative. You choose to do that if it makes more sense to you. But usually, oh wait, hold up. Can you explain why it's a positive cosine if the way you graph it has a y in starting at the minimum? Okay, so the 0, 2 thing I did was to show your shift. Was to show how your time thing works. We're not starting from there. So our graph is only this little part over here. Our graph is only this part over here. That 0, 2 is if we were to do that. But if we wanted to get a graph that starts like a cosine, we would have to shift this entire function 1/4 to the left. Would the shift be based off the parent graph, which would be negative cosine? Why couldn't we start at f? Yeah, that's what you're trying to do. You're trying to start at f. Because remember, cosine starts at when x is equal to 0. You're at a maximum point. So we want to shift to the left. Because we want to make this point go to here. And if we were to look at this graph, right, this would tell us to go 1/4 to the right. Because remember, if we had a negative 1/4, that means we went to the right. And also for the point system, if you got B and C, that's another +1. So B and C are 1 point together, the horizontal transformations. Okay, I'll show the rubric a sec. Hold on. Let me show the rubric. Maybe this will help some people. This is the rubric for part B. Okay, so the reason you did a phase shift is if you were at 1/4, right? That's not your that's not the maximum of a cosine. A cosine always starts at x is equal to 0 at a maximum. But at our at our f value maximum, it's at 1/4, which isn't our maximum. It has to be at 0. So we have to shift it to make it 0, which means we subtracted 1/4 to go to the left. And this is the rubric. If you want to look at the rubric, it would start at, you first find your D and A, which are easy ones, and your B. And then the way he does it is he plugs in his numbers and solves for C. So that's another way you can do it. You can solve for it if you choose to. So if you find it easier to do algebraic manipulation, you can choose to solve by plugging in a number. Because a cosine graph always starts at 0. Like it starts at its maximum and goes down. And a phase shift makes it so we have the graph what it looks like over here. So wait, hold on, let me pull up decimals. So let's, for example, let's say you had cosine of x, right? Minus pi. Is this a cosine graph? If we would just look at this little part over here, is this a cosine graph? Or could we tell based off just this information? Oh, is it not sharing a different screen? Oh, okay. Hold on. Let me change how I share my screen. Okay. let's say you had a cosine graph, right? You wouldn't be, if you just, let's say this is point F, this is point G, and so on. So we have 5 points. Could you tell this is a cosine graph? If I was to hide this and just showed you this, would you be able to tell this is a cosine graph or a sine graph? If I just showed you these 5 points and nothing else. Maybe, right? But if I was to tell you there's a shift to pi, so now let's say I tell you there's a shift of pi to the right. Now you can tell it starts here. So that's what you're doing. You're just shifting it. You're shifting the graph itself. So that's what you did. You're just shifting it to the origin, because that's how we think about cosine and sine. We think of it originating from the center. Yeah, because x has to start at 0, exactly. Because you have to make sure your function meets the cosine's rule, which means it starts at 0, it goes down, and goes to minimum. Alright, cool. Yeah, it has to map, exactly. It has to match the same. So whatever translations and stuff you do, they have to match the original function. Alright, cool. That makes sense. Then we're going to continue on. So now part C. Part C refers to the graph. It says on the interval from t1 to t2, what is happening? On the interval from t1 to t2, it is positive and decreasing. And the reason for that is, if you really look, I'm going to erase some of these lines so then I can actually like point out stuff, because it's kind of hard to point out stuff with all this stuff here, but it says T1 is F and T2 is G. So we're looking at this. I'm going to do this different color now. Oops. All right. It says T1 and T2. We know it's positive because our interval is positive, because none of our values are negative. And then the function itself is decreasing because our value is getting less. So it's B. And for part I, or double I, it says describe the concavity of the graph and determine whether the rate of change is increasing or decreasing. It's concave down because it's down faced. It's down faced, and that means your slope is decreasing, because we went from like a very positive number, and then we went to 0, and then we got less and less. That means our slope is negative. So we would say the graph is concave down on the interval from t1 to t2, and the rated change of h is decreasing. And that's because I'm going to do the thing that makes it pretty clear. Is, okay, I'm going to do this in different color. So our first slope, let's say, is like 4, right? Our second slope is like 2. Our next one is like 0.5. Our next one is 0. Our next one is, let's say, negative 0.5. And the next one, let's say, is like negative 2, which means our rate of change is decreasing, which means it's concave down. And you would say the graph of h is concave down on the interval t1 to t2, and the rate of change of h is decreasing on the interval. For calc, do they give you FRQs on any topic? It'll be the same formatted FRQs. So it'll give you a function, a periodic context. Are you saying calculus or like calculator section? RC is decreasing because the slope. It's you would say the slope. You would say okay. If the slope is negative, doesn't mean it's decreasing, because yeah, calc A, B, B, C. It can be any topic. So let's say, for example, we had let's say you had a concave upper graph, right? In this section right here, right, it would be negative slope, but it's not concave down. It's about the slope itself is decreasing is what makes it concave down or concave up. Because here we went from -5 to -3 to -1 to 0, which means our slope is increasing in value or in magnitude. It's increasing in rate. Okay, so now that we finished FRQ3, we're going to do a second FRQ, and now we're doing another poll. So FRQ1, FRQ2, FRQ3, and FRQ4. And it's the same poll system. Whichever one wins is the one we'll do. So whichever one wins is the one we'll do. And you can try to convince other people if you want. I don't really care. You can try to convince other people. I don't really care. Okay, FRQ4 is winning. We'll do whichever ones keep winning. And if we don't get to all of them by 4:30, I'll do the whichever one isn't done. So okay, so FRQ4 is winning by a majority. So we'll do FRQ4. And I'm gonna go there, man. We'll do the last one. This looks like a fun little one. So you will get, this is version model H. So you will get another 8 minutes again. Is this year likely hard? They're supposed to stay the same about each year, so I wouldn't say it's gonna be too hard. They're supposed to stay about the same each year. Okay, so 10-minute timer this time for all 3 parts. I would disagree with you on the A push, but alright. Remember, let's not talk about FRQs that aren't released. We can say like general stuff, like always. Okay, 10 minutes to solve all 3 parts of FRQ4. Yeah, I can put a screenshot. For this one, you have to show your works because that's part of the rubric. So show your work. And now for the next 9 minutes, it's questions time. So if you have any questions about the exam or anything. Yeah, no calculator for this FRQ. You don't know a single thing here. You're already lost. All I'll say is just try your best. Okay, I'm gonna open a blank page because I think this is gonna need some work. So hold up. Okay, I'm gonna leave it here, but I'll do the other 2 later. Okay, that's just timers, so I'll have to actually say how long it is. I have 6 minutes left. Okay, 5 minutes left. I have 3 minutes left. This is actually a kind of a hard FRQ4, I'd say, so. But we'll get through it. One step at a time. More time. I'm gonna only give 10 minutes so then we can get more FRQs done in the time. So it's fine if you don't finish, because you get 15 minutes on the exam. So, like, it's getting 5 less minutes for each of these is pretty much the idea. You get 30 minutes for both FRQ3 and FRQ4, so you can split your time however you want, but it's around 15 minutes per question is like the average. Okay, 1 minute left, or like a minute 20 left. 30 seconds left. Get your final answers out, and then we will get on with it. So I'm gonna do the first question, and I'm gonna start over here first. So our first question asks us to find g of x, which is our top function, equal to -4. So we're gonna set equal to -4. How much to it? It's 2 secant of x minus pi over 3 equals -4. Now we're gonna divide by 2 on both sides to isolate our secant x. Now we're gonna say secant of x minus pi over 3 is equal to -2. And now, if you remember, secant x is equal to 1 over cosine of x. So we're going to flip it. Cosine of x is going to be equal to x. Oh, wait, oopsies. Cosine of x minus pi over 3 is equal to -1/2. Because we flipped it. We flipped our entire thing pretty much to the other side. I'm going to stop here and wait for questions before we get on to the next step. Yeah, it's a reciprocal, exactly. Our next step is now to solve. So we're going to take... Oh, you have a question. Okay, wait, hold up. Wait, what are you confused about? Okay, let's take an example. Let's say you have 1 over x equals 1/2, right? How would you find what x is? Cross multiply. Okay, so if you want to do it like that, you could also do it like that. So we could say it's 1 over cosine of x minus pi over 3 is equal to -2. Now if you cross multiply, -1/2 equals cosine of x minus pi over 3. Cosine of x minus pi over 3. Our next step is going to be to take the arc cosine of both sides. So I'm just going to say multiply by cosine inverse, but you should put your argument in here, but I don't have space for that. So cosine inverse of -1/2. So now we're going to think about what pi values give us -1/2. Yeah, 2 pi over 3, 4 pi over 3. So now our cosine inverse will cancel our cosine. So now we have x minus pi over 3 equals 2 pi over 3, comma 4 pi over 3. And now we're going to add pi over 3 to both of these answers. And x is going to be equal to pi, comma 5 pi over 3. And that is part A. Any questions about part A.I? We'll do part A.I next. Okay, so we took the arc cosine of both sides, right? So we took the arc cosine of our left and right side. Because remember, your trig functions, if you were to take reciprocals, they act like your multiplication division. Sure. I'll erase this. So, I'll erase all of it and do it again pretty much. Alright. So we know this is now equal to cosine of x minus pi over 3, which is equal to -1/2, right? We know, do you understand until this part? Yeah. Yes. So our next step is we're going to take, I'm going to actually rewrite this as a bit more space so I can actually write it correctly. So we're going to say cosine of x minus pi over 3 equals negative 1/2. And now we're going to take the cosine arc sine or arc cosine of both sides. And you can do that because they're like, it's like multiplication or division. You can do it to both sides. You just have to do it on both sides always because you have to keep it equal to each other. Does this make sense? So yeah, take the inverse arc. Yeah, take the inverse cosine of both sides. Yeah. So now you're going to do that, which means these cosines are going to cancel out. And this is going to be equal to 2 pi over 3, comma 4 pi over 3, which is going to be equal to x minus pi over 3. What do you mean it's gone? What's gone? Oh, the bug. I'm going to guess. Never mind. So now you're going to add pi over 3. Quick question. Isn't arc cosine restricted? Yeah, that's why you have to restrict it when you did this. That's why you're only taking 2 pi and 4 pi over 3. That's your restriction. That's your domain's restriction. That it's only between 2 pi over 3 and 4 pi over 3. Because remember, cosine is your like entire top half, which should be 2 pi and 4 pi. Because it's asking for intervals in the 0 to 2 pi. So you can get 2 pi and 4 pi over 3 because it's in the domain of 0 to 2 pi. If it was just saying 0 to pi, it's just the whole unit circle, exactly. So it's just asking you what values of x have negative 1/2. That's what it's asking you. Which values on the unit circle have where x is equal to negative 1/2? What pi values? Which would be 2 pi over 3 and 4 pi over 3, which is down here. And then you're just going to add pi over 3 to all your terms. So that's going to be x is equal to pi, comma, 5 pi over 3. Any questions on that? No problem. All right, cool. If there's no questions, we're going to continue on to the next part, which is a dot I, which I'm going to have to take a nice screenshot of because I took too much space in the first one. So our next step is, it says set equal to 1. So we're going to set equal to 1. We're going to say log 3 x plus 2 minus log 3 of x plus 1 is equal to 1. Oh, you have a question? All right, no worries. What's your question before I continue? It's arc cosine. This is meant to be arc cosine, not 1 over cosine. This is arc cosine. So this would be the same thing as saying arc cosine. You can, there's two ways to write arc cosine, which is because arc cosine and cosine are reciprocal functions. That's like when you do your let's say you had x squared and square root of x, right? Those are your reciprocal functions. No, these are your inverse functions, right? X squared and square root x. So if you were to plug one into each other, you would get a solution of x, which is why you get x minus pi over 3 as your solution. Yeah, reciprocal, yeah. Reciprocal is 1 over x and x. Yeah. We're not canceling out to 1, we're just taking the interior of it, pretty much. Yeah, it's cool. So next question is asking about the log, and we're gonna first combine it. So we're going to say log, we're going to condense it first if you want to use that term. It is log 2 of x plus 1 is equal to 1. Any questions about this first step? I'm going to do this question by step this time. Nope. Yeah, it's a log. And now you're going to take each side to the power of 3 to cancel out these logs, because exponentials cancel out logs. Or you could rewrite it using the log to thing, but you can also just raise each side to the power of 3. So these are going to cancel out. Now you have x plus 2 divided by x plus 1, which is going to be equal to 3. Any questions about that? Do we do this? I've never heard of what the snail method is before. So yeah, then it's just a rational expression. You're just going to cross multiply and solve for x. So x plus 2 equals 3x plus 3. No, 3 to the power of 1. What's 3 to the power? We're raising both sides to the power of 3. So what's 3 to the power of 1? Okay, and then you would solve for x, which would get you x is equal to -1/2. Cool. So that's part A.I. Any questions on logs or the first trig question? I'm going to give a minute for questions before we move on to the next part. You have to make sure it's in the domain. Yeah, so you have to plug it in. So you plug it in. This would be positive because -1/2 plus 2 is positive, and -1/2 plus 1 is still positive. So yeah, it's still positive, so it works. Our next step, we're going to do part B now. So I'm going to take a screenshot of this and I'm going to do part B. I didn't solve it out, but it's just equal to x is equal to -1/2 if you were to solve it out. Because you would subtract your 3, subtract your x, that would be -1 equals 2x divided by 2. X is equal to -1/2. So now the next part asks us to do some more math. But now we're just doing some symbolic manipulation, as they like to call it, where you're not solving anything, you're just going to be rewriting. So for the first one, it says rewrite it as a product involving secant x and cosecant x and no other trig functions. So we have tan of x plus cotangent of x. What is tangent of x equal to? Sine over cosine, yep. Sine of x over cosine of x. What is cotangent equal to? Cotangent over sine of x, yep. Okay, now find the common denominator. What's the common denominator? Yeah. Sine x cosine x. What's our numerator? You skipped a step. You have to, yeah, sine squared plus cosine squared, yeah. Sine squared of x plus cosine squared of x, which is equal to 1 over sine x cosine x. And then we can split that to 1 over sine of x times 1 over cosine of x, which is equal to c secant x times secant x. Any questions about that? This is low-key my favorite FRQ. It's very simple. There's not much context, which I like. It's you know it or you don't. Yeah, it's usually just find a common denominator or simplify. Okay, next part. This was b dot I. B dot I. So now we're gonna do b dot I dot I. And it just says rewrite it in terms of ln, and you can only have one ln. So we have 3 ln of x minus 1/2 ln of x plus 4 plus ln of 2x minus 1. How did we get the 2 squared on bi? Oh, we would cross multiply, because if we make this sine x cosine x, we have to multiply this entire thing by sine x on the numerator and denominator, which we get you sine squared of x, and you would do the same thing on the other side. Oh wait, I'm gonna let this last. Alright, so your next question is asking you to do it again. And your first step is we're gonna try to simplify. So what can we simplify first? What can we simplify with this thing? Or this first term? What's the easiest thing we can do? Exponent inside x to the third. So yep, ln of x to the third. Alright, what can we do the second term? I'm pretty sure the MCQs are worth more. Yeah, put the exponent as 1/2. So now we have ln of the square root of x plus 4. What can we do with this last term? Yep, keep it as it is. You can't do anything. Alright, no, okay, hold up, yeah, we'll get to that. Our next step is now to condense everything together. So, we have a division sign because we have a negative. So that means this is gonna go in the, alright, so now this first one is gonna go in the numerator. I'm gonna do this in different colors actually for the sake of it looking nice. So, this first part is gonna go in the numerator because it's positive. This one is gonna go in the numerator because it's also positive. So you're gonna have x to the third times 2x minus 1. This one is negative, goes in the denominator. So you're gonna have ln, oh wait, no, ln, the square root of x plus 4. And that's your answer. Any questions about b dot I dot I? See, it can all be simplified. You just don't overthink it. That's what my tip is. Don't overthink it. They're not meant to try to trick you. Pre-calc, it's not allowed to be tricking you a lot. You don't have to rationalize. The radical is in the denominator because you have your 1/2 and you have to bring it inside. And 1/2, anything to the power of 1/2. Is there a negative exponent here? Is there a negative exponent? That's the question. If you, let's say you had ln of 1 over, let's make it a exponent. Is this a negative exponent? That's the question. It's positive. That's what it means. No, if it was like this, they're saying don't do this. They're saying don't leave it like this. They want you to bring it down. That's what the point of it is. They just want you to bring it to the denominator. That's what no negative exponent usually means. Okay, so now we're gonna go on to the next part. Radicals and denominators are bad. There's nothing bad about it. It comes up a lot actually in calculus and pre-calc. It's a pretty useful thing. Okay, and our last question is a lot of algebra. So let's get on with the algebra. A lot of trigonometric manipulation. So what's our first step, guys? Expand, exactly. Yeah, or yeah, you can say, yeah, we can expand or set equal to 1/2. Same thing. So we're gonna say it's gonna be expand it first. Well, if you expand it, what would you get? Yeah, set equal to 1/2. Okay, we can skip that step. That's like kind of common sense. But what's the first algebraic step? Someone factored out, and then what would it be factored out? Yep, sine squared. Yes, sine. So we have sine squared of x plus 2 sine x cosine x plus cosine squared of x, which is equal to 1/2. Okay, now what can we do? Simplify the what? Yeah, factor. So this is all going to be equal to just 1. Oh yeah, and on the test, do not do the x's, because if you do x's, that means they're not going to look at it. So say it's 1 plus 2 sine x cosine x, which is now equal to 1/2. Now what can you do? Subtract 1, yeah. 2 sine x cosine x equals negative 1/2. Now what can you do? What can this simplify to? Sine 2x, yeah. Should double the angle identity. Okay, and then what can you do now? Arc sine, yeah. So we're gonna multiply both sides by arc sine. I'm just gonna write it over here. Say, take arc sine of both sides. So now your sine's gonna cancel out. So now you're gonna have 2x is equal to, what's the arc sine of negative 1/2? 7 pi 6, 11 pi 6. Yeah, okay. But there's one more thing we have to do for this. It says for all input values. Yeah, plus 2 pi over k, exactly. And where k is what? Where k is what? And an integer, yeah, is an element of the integers. Now you're gonna divide by 2 all of this stuff. So I'm just gonna divide this by 2. So now you're gonna have x is equal to 7 pi over 12 plus pi k 11 pi over 12 plus pi k, where k is an element of all integers. All right, any questions about, I'm gonna zoom out a bit so you can actually see the entire process. Any questions about this? Yeah, that was a lot. Oh, wait, you play Valorant. Nice. I would recommend writing it because it is part of the expression. So I would say write it. You could also use n. That's what the rubric here uses. Oh yeah, for points, each part is worth 1 point, except part 2, which this 7 pi 11 pi over 12 is 1 point, and your pi k is another point. Wait, hold up. I thought we could put where k is an integer, or I'd have to use what an element is. I would write it as that. That's like just the way I was taught how to write it. You could say k is an integer. That's the same thing. What you're saying here is you're just saying k is an integer. You're just saying k is an element of the set of integers. You're saying k is an integer, pretty much. That's all you're saying. It's not anything different. I have a question, but it's question 1, part B, the I, where they ask the limit. Do you have any questions for that? That's just about end behavior. So you're just looking at where the function's going. Okay, now third FRQ. Oh, wait, I'll answer your question as I called up, but let me just type out the poll. Alright, Out of all the FRQs, which one you say the hardest? Depends on your skills. For clarification, why do you write 2? Because it says it's asking for all input values in the domain. So domain is all values. So right now, I'd recommend everyone to vote in the poll real quick. That's going on. We have 15 votes. Poll FRQ3 is, FRQ4 is winning again by a good majority, so we'll do another FRQ4. So we're gonna do an FRQ4. We'll do this one. This one looks fun. I need to see the model. This is F. Okay. Okay, another 10 minutes. Starting now. And in the meantime, I will answer questions while we wait for that. And oh yeah, make sure to fill out the lecture feedback form before you leave. All feedback is appreciated, critical or non-critical. I have screenshots. Yeah, I'll do that real quick. Part A. Part B. Part C. Remember, A has 2 parts, so Alright, for your question, Taylor, with the for the limit, you would just graph it in Desmos, and because it's an exponential function where it's decreasing, it's going towards zero because a function, an exponential function without a shift will always approach zero if it's going, if it's decaying towards positive infinity. With tan squared of x simplified to sine squared of x. Which question has tan squared of x? Which part? B dot I. Yeah, I would simplify to sine squared over cosine squared. Because remember, you're squaring it, so you have to keep the square going. Follow the fundamental. Just keep it simplified. Okay, 4 minutes 30 seconds left. It's mostly just trigonomic identities and like solving, so it's like log mix of all that stuff together. It's your trigonomic identities, unit circle values, and like log properties. Pretty much, that's pretty much like this entire unit. Okay, 2 minutes 30 seconds left. Only do A. Okay. Yeah, these do look a bit harder, but okay, there's still a minute 30 left, so I will give those people who need the minute 30, and then we will start. Okay, 1 minute left. YouTubers would you recommend for doing FRQs and MCQs? I don't know any YouTubers who do MCQs or FRQs for pre-calc. Sorry. For content, there's like Michael, like Fortunak or something, or Maximum Insight, or like I think Math Teacher Goat does some MCQs and FRQs if I remember correctly. Time's up. So now I'm gonna go through it again. I'm gonna start with part A. So I'm gonna split this down the middle for each part. So for A dot I, our first step is of course to set equal to 1. So 8x times 2x divided by 8 over 5 equals 1. Our second step will be to cross multiply, or we can simplify the numerator if we want to. Because if you multiply two things with the same base, you can also set them equal. You can also just add them. So 8 to the 3x is equal to 8 to the 5. Now, because they have the same base, you can set the exponents equal to each other. 3x equals 5. X is equal to 5 over 3. Any questions about this first part? Nice. Okay. I'm gonna give like another 10 seconds to ask your questions. How does 8 3x? Because we cross multiplied. We're gonna cross multiply from like this, and then we're gonna add these two. We're gonna multiply these two together, which means we add the exponents. How do you get a log? You could also take the log of each side. You could say it's log 8 of both sides, which would get you the same thing if you want to do that. You could do log of 8 on both sides. That's pretty much what I did if you like think about it like that. But yeah. You got log of 1. Interesting. Okay. Any other questions for this part? If not, I'll move on to part 2. And this is also 1 point. Next thing, we're gonna set it equal to 2. So we're gonna say log 4 of x plus log 4 of 5 is equal to 2. Now we're gonna add the two bases together, which means we're gonna do log 4 of 5x equals 2. Now we're going to raise both sides to the power of 4 to cancel out the log, which would get us 5x is equal to 4 over 2. 5x equals 16. X is equal to 16 over 5. Any questions about this one? Or about these two in general? So part A dot I and part A dot I dot I. Okay, let me give another. Nice. If these are light work, then nice. We're gonna continue. You're supposed to box your answers. You don't have to. They'll look for the answer always. So, up to you. Yeah, that like if you think, yeah, that's one thing. If you box your answers, they might not look at your other answers. And this is also 1 point to solve this part. So now I'm gonna take a screenshot of the next one real quick, which is gonna take like 2 pages, but it's fine. So we're gonna do first part b dot I, and it says make it in terms of sine of x. How many people got this question, first of all? Or think they did? Before I start, you think you got it? Think, okay. Think I got it? Okay. You got half of it. Okay. So our first step is, I'm not going to rewrite it for the sake of it, but our first step is going to be to turn everything in terms of sine and cosine. So this is going to be a long one, but you have a lot of stuff to do. So I'm going to write this out like this. What is tangent squared of x equal to? Sine squared over x over cosine squared of x. Okay, that's your first part. What is secant squared of x equal to? Okay. 1. So we don't care about the 1. So we're going to put the cosine squared of x down here. What does secant x equal to? Sine of x. Yeah. So we're going to bring that to the numerator then, because if it's 1 over sine x, we're going to bring it to the numerator. Okay, any questions until here? Is precalc different than AB? Yes, it is. Precalc is more like it's like the algebra behind calculus. Okay, any questions until this first step? Taking out all your secants and stuff like that. Nope. Okay, there's no questions. Then we'll continue. So now you're gonna multiply it out. So now you're gonna have sine 3 to the x divided by 2. What is cosine squared of x equal to? 1 minus sine squared of x. Yep. So 1 minus sine squared of x squared, because there's 2 of them. And then we're going to simplify it out. So we're going to say sine of 3 of x is equal to 1 minus 2 sine squared of x plus sine 4 of x, which is now all in terms of sine. So we're done. And I'm not going to box it, but yeah, that's the answer. Is that it's sine to the 4th? Sine to the power of 4, because you're multiplying sine squared of x by sine squared of x. Why isn't it's in the denominator? I would recommend multiplying it out because it says here combine terms using algebraic method and rules where applicable. So I would say do it. See, the thing is, if you do it, right, and you mess it up, you still have the original answer still. So if this was wrong, you still have your original answer somewhere in the page, so you'd still get it right. Yeah, they look for the stuff that they look on the rubric. So, for example, the rubric for this thing looks like this. This is what the rubric looks for the first 2 parts. So Yeah, they'll just ignore your wrong answer. That's why you don't. That's why you don't box it out. Alright, so now we're gonna continue on to the next part, which I'm gonna have to paste again. Our next one is another trig one, and it asks us to write it in terms of cosine of x. So what is sine 2 of x equal to? Okay, so 2 sine of x cosine of x times sine of x. Okay, now what can be simplified? You can leave the 2 out. What else? No, it can't cancel out because it's not in the denominator. Yep, sine square root of x cosine of x. Okay, what is sine square root of x equal to? 1 minus 2, 1 cosine, yeah, times cosine of x. What is this equal to? So distribute all your values pretty much. Yep, 2 cosine of x minus 2 cosine to the third of x. Okay, any questions about this one? Before we get to part C, which is pretty long, which I do agree. That's it. That's all. That was all for that I. How did we get 2 cosine x only? Because you would multiply this into this and this to here. Because you could also, if you wanted to, you could say this is 2 cosine of x, 1 minus cosine squared of x, if that makes it easier to distribute. Remember for tips for remembering identities? They simplify it down to like very basic ideas. So for example, our double, it's mostly just memorization. Just sit and practice writing it down as many times as you can. Keep practicing with it, which is very helpful. And you pretty much just, let's say you have your identities, right? Like your, sure. So let's say you had your identities, right? So like you have like 6 identities you have to remember. Like your tangent, cotangent, reciprocal identities are super important. Like those will show up no matter what. The other thing you must know is your double angle for sine and cosine. And finally, you know your sum and difference for sine and cosine. And that's really it. Like you don't really need to know your tangent for those. It's rare to see tangent for those. So, and even if you do see tangent, you can convert it into sine and cosine, and that's really it. Yeah, it's unlikely to see tangent identities. Tangent identities are rare. And yeah, the sine squared plus cosine squared is the most important one. Yeah, it's rare to see those, but you just have to know that you can convert between them. So you can always convert your cosine, your secant into a cosine. So are inverse trig identities coming? I don't think so. I've never heard of something called inverse trig identities, unless like talk about arc cosine, arc sine. Oh, do you mean the like if you have cosine of like cosine inverse of like x, like stuff like that? Those things are just based off your triangles. So like best tip for those is like draw your triangle and figure out where your cosine and cosine inverse would be of those. Alright, now we're gonna do part C. One that I think everyone's been waiting for, which has two sum and differences. Alright, so what's our first step? Okay, like let's say we set to equal. Yeah, set equal. We'll skip that step. From there, what's our next step? Cosine of A of B. Yep, yep. That's the sum. Yeah, we convert them using sum and difference. So I'm gonna do this at this form. What is this first one simplified to? Yep, that's pretty much it. So I'm gonna write the value first, actually, for this simplicity's sakes. I'm gonna change colors for this actually. Minus sine pi over 3 sine of x. Okay, what about the second one? What does that simplify to? Like the entire thing, like what is this section simplified to? Like if we were to sum and difference it, we're gonna first simplify it, sum and difference. Yeah, exactly. It would be cosine of pi over 6 sine of x plus sine pi over 6 cosine of x. Which I didn't write in different colors, so let me put that in different color. Kind of ran out of space, so oopsies. X. Hopefully that's readable. So now, any questions on how we got to this very long algebraic manipulation? Yeah, it looks really bad, but it's really just sum and difference. It's called sum and difference. It's like this is sine, this is cosine sum, and this is sine sum. So I'll pull up a picture of those formulas real quick. Wait, is this one? It's these formulas. Ignore the ads, just popped up, but so it's just these. You don't really care about tangent, you just care about these top two. So we used this formula and this formula. And we just plugged in numbers. I just rewrote it like that because when we're going to simplify it, it's easier to keep the coefficient in the front. Because then it's going to be, looks like it's part of the x. That's the only purpose of that. So it looks nicer pretty much. That's, no, I just flipped all of them. So then the number is in the front. Okay, so now we're going to simplify this. What is cosine of pi over 3? Yeah, sure. I can send this screenshot. 1/2. Okay, what is cosine? We keep that the same because we can't simplify that yet. What is sine pi over 3? Square root of 2, yeah. Sine of x minus, what is cosine pi over 6? Root 3 over 2, yeah. What is sine of pi over 6? 1/2, yep. Which all is equal to 3 over 2, because now we have space to write that, so. So now we have to simplify this side. So what's the first thing we can simplify? Let's look at cosine first. What can we simplify with cosine? The other 1/2. Okay, so we have a 1/2 cosine x and a negative 1/2 cosine because we have to distribute this. So what happens if you add a negative 1/2 cosine and a positive? Yeah, cancel it out. Alright, what happens with the next one? Negative square root 3 over 2. I'm going to do some different colors so you actually see it. If we have a negative 3 square root and we subtract it, what happens here? No, it doesn't. Because it's a negative, so we have to distribute. It's alright. What can we do? You can add them, yeah. Negative 3 over 2 sine of x minus negative root 3 over 2 sine x is going to be equal to 3 over 2. What is this equivalent to? Yep, negative square root of 3 sine of x is equal to 3 over 2. Okay, now what can we do? Yeah, the 2's cancel, yeah, because you're adding a half and a half, which makes a 1. Yeah, divide by negative square root 3 over 2, yep. What does that get us? Sine of x is going to be equal to what? What is all of this simplified to if you were to do that? You're going to have to simplify this. You're going to have to do your rationalizing, your denominator, and all that stuff. Nope. I'll say when someone gets it, so. I'll say when someone gets it. You just simplify it all the way. Close. Someone's close so far. Yeah, negative root 3 over 2. Anyone want me to show how to do that? Yes, okay. So you have through negative 3 over 2 square root 3, right? Because we divided it, so we're going to keep in denominator. So now, our next step is to multiply by square root of 3 on the top and the bottom, which would get us negative square root 3 divided by 3 times square root 3 times square root 3 is 3, so this would be 6. These will cancel out to get you negative root 3 over 2. I got that for the last FRQ video part. Wait, I got that for the last FRQ video for part C, so does that? For the last FRQ, like, we might like the one we did like before this, or like last part. This was the last FRQ scoring rubric. I'll just send it in the chat. All right, I'm gonna continue. So for this one, how do you find what x is equal to? Yeah, arc sine. So we're gonna take the arc sine of both sides, which means it would be x is equal to, what's the arc sine of negative square root 3 over 2? What sine values give you negative root 3 over 2? 5 pi over 3 is 1. There's still one more. There's 2 always. Yep, 4 pi over 3. So we have 4 pi over 3 plus 2 pi k, comma 5 pi over 3 plus 2 pi k, where k is an element of all reals, or where k is an integer, whichever one you want to say. They're both the same. Which would be your final answer. This entire bottom thing over here. And you would get 1 point for the solution, and 1 point for saying the 2 pi k and with the integers part. Alright, any questions on this FRQ? And while you guys ask your questions, yeah, you can say k is an integer. If you don't say the k thing, then it's not a general solution. So you would lose 1 point for that, or you wouldn't gain 1 point. You don't lose a point. You don't gain 1 point. Alright, which is the fourth FRQ we're gonna do now. Whichever one wins, and we're gonna go until 5:30, so another hour. Because I do need to prepare and make a polar lecture and study for calculus as well. So that makes it both. What happened from negative square root 3 divided by 2 sine x? What happened from negative square root 3? Okay, so from here, we added them together, right? Because if we did a negative square root 3 plus a or minus square root 3 over 2, we would get negative 2 square root 3 over 2, which would these would cancel out to make negative square root 3. And then we divide it by negatives. I'm going to do this in different colors so you actually see it. We divide it by negative square root of 3. Then we rationalize to get this number. From there, we did arc sine of both sides. To get these solutions. Yeah, pretty much. No problem. Cool. Okay, so there's a perfect split between FRQ3 and FRQ4. So, could someone that hasn't voted, yeah, I can zoom out for a sec. Sure. There's a perfect split. So one of the people who haven't voted, there's 18 people in the call. Could someone break the tie between FRQ 3 and 4? There's 18 people in the VC, so could someone break the tie? Okay, FRQ 3 won. Okay. So we're gonna do an FRQ 3 now. Yeah, I said yeah for that. You would do for everything that's not secant, tangent, or cosecant. For everything except tangent and cotangent, you use 2 pi. Secant, cosecant, sine, and cosine all have periods of 2 pi. It's based off your period, pretty much. Okay, so FRQ 3. We will do another weird one. The Ferris wheel already. I'll go to this one. This is a fun one. I remember this last year. It's a fun one. I'm gonna send all the questions in chat right about now, and there's no calculator, so context. Part A. Part B. Let's see. All right, and you're gonna get another 10 minutes now. So, yeah, I'm just gonna zoom in on the context only, so you guys can just do questions. And this graph this time is a sine graph. You got this question from your go-to teacher. Nice. Well, then this should be pretty easy then, right? Because you've already seen this before. I think a lot of teachers use this blind password questions, so damn nice. Yeah, I think you're using the same packet I am, pretty much. All the FRQs are from that packet, so. I see. Make sure to fill the lecture feedback form before you leave. You could do decimals if you really wanted to. With the max. For your question, it would be no. Okay, I'll be back in like a second. So yes, I'll be back in a second. I'm back. Yes, for your question, yes. And reminder, there's 4 minutes left, so. Okay, 2 minutes, 20 seconds left. I have 1 minute left. I have 15 seconds left. Time's up. So now let's go through the context first. So it says first, there's 50 rotations every second, which means this is our frequency, which means our frequency is 50. And frequency is equal to 1 over our period. So that means our period is going to be equal to 1 over 50. So that means every 1/50 rotations finish every, yeah. It takes 1/58 seconds for one rotation to be finished. That's how you say it. So that is our period. So we know this. Next, it says at t equals 0, b is at its lowest point, 30 feet directly below. So we're going to say that's -30, and this is 30. So we know, let's do our y coordinates first, because that's usually the easiest. We know this is going to be -30. This is going to be 30, 30. And it means the midline will be 0. Any questions about that? Is there any questions about the y coordinates before we get to the x? Because x is its own little world. If you got the y coordinates, you got 1 point. Okay, no questions, seems like. So we're going to continue on. So now, x coordinates. This is where it gets a bit harder. So it says at t equals 0, b is at its lowest point. So we don't want negative time. So we're going to say, we're going to graph it out a little bit. So we know at t equals 0, that's the first time it's a minimum. It's also -30. So we also have like a point here. Let's say that. So we can assume there's another point here. And it says at its highest point, and it says it completes a rotation. We complete the rotation every 1/50th seconds. So that means this is going to be 1/50. I'm going to leave it in fractions because it's easier to read. So this is going to be 1/50. Any questions about that? Okay. So now if there's no question about that, what's halfway to 0? Between 0 and 1/50? 1/100, yeah. 1/100. Because done one full rotation. Yeah, from here to here, it's one full rotation, or one full wavelength. Is another way to say it. Or full period. Same thing. They're all the same. Alright. So now, we know this, we know this. What's P? What's going to be P? If this is 1/100, this is 1/50, what is this going to be? 3/100, exactly. Because it's going over skips by 100. Yep, okay, what's going to be G then? Yeah, 3/200, exactly. Apologize for the bad handwriting. Okay, and then what's the other one going to be? 500/200. Yep, alright. What are you confused about? So we got our first point. Did you understand how we got F? We went between these. Okay, then from there we went to P. We went from F, and now we're going to find P. We know this distance is 1/100, right? This entire distance. I'm going to rewrite this. You know, this entire distance is 1/100, right? That means this distance from this point, I'm going to do it like this, has to also be 1/100, right? So we have to add that to 1/50. How is J 1/50? Yeah. So you started at 0, because it says at t equals 0, it's at the lowest point. But we don't want negative time, so we're going to say this is 1/50, because we're going to shift it for this one period. I'm going to erase this blue stuff, because then it's going to be really hard to read the next step. Alright. Any question about the coordinates so far? Yeah, you could also do it in terms of 200, but this is just like simplified. So 2 over 200 is equal to 1 over 100. Well, it doesn't really matter if it's sine or cosine function. Because it says at its lowest, at t equals 0, b is at its lowest point. So that's, your 0 has to be down here. That's why. Does that make sense? Because if it was on the top, right, if it was at p, that means it would be at its highest point, not its lowest point. So, cool. So now we got our x and y coordinates. Boom, that means you got 2 points already. How did we get 3 over 100? 3 over, it's 3 over 200. Because we added 1 over 200. Because this distance is 1 over 100, so that means this distance is going to be 1 over 100. 200. And this is 1 over 100. Does that make sense? Kind of. What's confusing you? Yeah, it's just addition of 100. Okay. Our second part. Okay, what is a, guys? Let's get the easy variables out of the way. 30. Yep. Okay, what is d? 0. Okay. Boom, that's 1 point right there. You got 1 point just now. Alright, next, what's b? 100 pi. Yep, and the way you find that is you would do 2 pi over b equals 1 over 50. B is equal to 100 pi. Does that make sense? Alright. Now, C. The most fun variable to find always, right, guys? So, what does the sine graph look like? Yeah, you guys, yeah, it's negative 5 over 200. Yeah. It starts in the middle and goes up, so you have to shift until all the way to k, and that's it. So you got it. So c is equal to negative 5 over 200. Because it says sine graph right here. Okay. It could also be 1 over 200. That's another option. You could also have negative 1 over 200. You could have both. You can have either or. Doesn't really matter. You can have it at this point or you can have it at this point. Because you have to shift, because remember, sine graph starts at the origin and goes up, and this one goes down, right? So you have to make sure it's around the origin always. So this is our origin, let's say that. But this is not around our origins. Our origin's all the way over here. So right now, it's like a cosine graph. It's like a flipped cosine graph. So we have to shift this k value. I want to just highlight a color. We have to shift it all the way back to here in this direction. I'm going to shift every single point in that direction. like 1 over 200, the point before f. Yeah, you could shift this if you wanted to. It would be negative 1 over 200 because it has to be to the left. It wouldn't be positive because positive would mean it's coming from over here. 3 over 200, yeah, would be a negative sign because this is going from the top to the bottom. But our sign starts, our normal sign function starts from the top, from the middle to the top, and then the other side goes from middle to the negative. Quick question, why can't g be 1 over 200? If g was 1 over, g can't be 1 over 200 because our f is 1 over 100, right? So we have to increase it. 1 over 200 would be to the left. So that would be our, like, whatever comes, like e or something. It would be to the left. Because we have to increase by increments of 1 over 100. Yeah, if it was negative sign, you have to make a negative and all that stuff. What if we change c to be negative? Because we're shifting to the left. If we were shifting to the right, so let's say we had like a point here, like this was like a negative value, for example, then we could shift to the right to make it 0. If it was negative 1 over 200, no, because, okay, let's say we have like our x, let's take our basicest form that we've learned. Let's take our quadratic, right? X minus 2 squared plus k, right? Times a. I'm going to make these numbers, right? Let's say plus 1, right? If it was negative, we're shifting to the right, right? Because this would be the vertex to 2. This would be, the vertex would be 2 comma 1, right? But if we had a positive, this would be negative 2 comma 1, which means we shifted to the left. And that's where it all boils down to, this vertex form. Yeah, c itself. C has to be negative because our c is positive here. So when we plug it in, it has to be negative to make it shift to the right. Because the standard form of a trig function is plus c, not minus c. No problem. Cool. FRQ3. The answer for this one is D. And it says from G to J, what is happening? So from G to J, we're at negative values and we're getting closer to J, which means our function is decreasing and it's negative. For shifts, is it based off where the x-intercept is 0, or it's based off sine and cosine? It's based off all around sine and cosine. Because cosine goes like this and sine goes like an S. So you have to match that. So that's how you tell where your shifts are. And then for this one, it's concave up, increasing. And that's all you have to say. Any questions about FRQ3? Since it's going down, it's decreasing. Yeah, that's it. It's not talking about rate of change. It's not talking about slope. It's just talking about where the function's going. Okay, now another poll. Answer the poll for our next FRQ. FRQ 1, 2, 3, or 4. I'm gonna give another 30 seconds for voting because only 9 people have voted out of 18 people in the VC. So, okay. Okay, FRQ2 is winning by a majority, so we will do FRQ2 now. Okay, we're gonna do this one. So I can actually fit that. I can fit the entire thing on my screen for once. So I'm just gonna screenshot the entire question into the chat. Okay, 10 minutes starting now. He loves to glaze himself in his FRQs and MCQs. That's his favorite thing to do in these MCQs and FRQs, just glaze himself continuously. Yeah, this is calculator. You can use a calculator now. Our first calc FRQ of the day. Would we use the log? Let me check. I haven't actually done a regression on Desmond in a while. Let me check. Yeah, you do a log. It auto adjusts to ln, so a log graph will automatically adjust to lnx. Okay, 7-minute warning, or not really warning, but 7-minute reminder left. B dot I is saying calculate the residual and explain why it's always negative. A 3-minute warning. Yeah, I use Desmos personally. 2 minutes left. I use a TI-84. You could also do a TI-84. I can actually pull up a TI-84 for this if you want me to. I can do on both TI-84 and Desmos for this question. Okay, I'll do on the TI-84. I'll do on Desmos first and then the TI-84. I'll do both for this one question. Well, you need a bit more for beta than just that. Time is up, so we're gonna go over it. So I'm gonna pull up Desmos and I'm gonna split screen this because I think that's the easiest way to do this. Okay, I have to zoom out once. Okay, hopefully you can still see it and it's not too small. Okay. We might do one more. I'll see. Depends on how long this one takes. So the first step is to first find the two coordinates. So our coordinates are 2, 230 and 9, 270. Does that make sense? Yes, cool. Now we're gonna make a table. And we're gonna type those two coordinates in. So 2, 9, and 230, 270. We're gonna click this button, says add regression, and we're gonna change it to a log. And I'm gonna do this once. So our A value, and it says A is this value and B is the other value. So A is our multiplication, so that means A is equal to 26.59, while B is equal to oopsies, where B is equal. I would just say write it out. That's easiest. You can rewrite it if you want, but I'd say say A equals B equal, because it says find the A value. 594 and 211.566. Not 565 because it goes until 6. If I don't write steps in A.I, that's fine, yeah, because you don't have to show steps. It just says find the value, and you have a calculator. So, okay, any questions for part A? Yeah, it's 566. Oh wait, oopsies, yeah, I flipped it. E A. Yeah, I swapped it. Oopsies. Okay. Any questions on part A? Does rounding affect your answer? I would say do the 3 decimals or 4 decimals method. Alright, so there's no questions. We're done with part A. For part B, the first part asks you to find the average rate of change. So you have to do, okay, there's like no space here, but it's like, oh wait, I forgot to write the equations. Oopsies. Yeah, okay. The way you would write your equations is you would just plug in your number. So you would say, so our equation is m of t equals a plus b ln of t, right? So we're going to say, we're going to plug in 2 comma 230. So we're going to say 230 equals a plus b ln of 2. And then we're going to say 270 equals a plus b ln of 9. And that's it for part A, part A.I. And then part B is just using a calculator. Nope, you just have to write it like this. Yeah, this is the free point pretty much on this question. Okay, part B is asking you to find the slope or the average rate of change. So you're going to say b of 9 minus b of 2 divided by 9 minus 2. I'm going to say m of 2 actually. Jeez. M of 9 minus m of 2, which we know is equal to 7 over 270 minus 230, which is equal to 40 over 7, or 5.714. Does that make sense? Okay, then you got the first part. Now it says to interpret. So for that, I'm going to add a note so I can actually just type here. So for when it says interpret, you click, there's like a, when you type your data, there'll be a button here that says add regression. For B dot I, you would say Mr. Pass, or you would say Passwater's maximum bench press is increasing because the slope is positive on average, because this is an average rate of change, because our function isn't linear, by 5.714 pounds per week from week 2 to week 9. And you have to put the week 2 to week 9 because it's in a domain, because you only calculate for this domain. Any questions about b.i.i? You would get this wrong if you didn't include the estimate, yeah. If you didn't include the domain, you would get it wrong, yeah. Because you're in a certain domain. So if you were to 2 to 10, week 2 to week 10, it would be a different number. It would be a different slope. I would say it could carry on average. Yeah, actually, no, you're right. Yeah. That also works. Yeah, never mind. You already said average gypsies. Okay. For the next part, for B dot I dot I, so triple I, it says calculate the compute the residual. We'll do that first before we explain. So how do you calculate residual? Yeah, observed minus predicted. Yeah. Yeah, observed minus predicted. Or yeah, actual minus predicted. Yeah. So it tells us we know that E12 is the estimate found after using that. And computed with the given by the model that we made. So we're going to do M12 minus E12, which would be M12 would be, we're going to find what 12 is. So we're going to go to where x is equal to 12, which is 277.65. 277.65 minus 287.14. And it's not going to calculate it, so I'm going to have to do it down here. But you get negative 9.49. Does that make sense? Actually, I need to cosine. Does that make sense how you calculate the residual? Because this model is our actual values, right? We're assuming this is our actual values between, and it says E is our predicted amount or estimate. So we know it has to be actual minus predicted or observed minus predicted. Okay, so now it says for this, it says over for t is greater than 9, the residual of the estimate will always be negative. Explain why this is true. And the reason for this is, you know how we said our slope was 5.714, which means our line is something that looks like this. So this is like this is what our estimate is, but our log or ln equation is gonna look like this. It's just gonna keep getting more and more negative. And the reason for that is the way you would say it is the ln function is concave down, so these average rates of change are decreasing, which means E of t is greater than M of t, which also means M of t minus E of t, or our residual calculation, will always be less than 0. And this would be b dot I dot I dot I. Don't have to specify. You could say. So the rate change is decreasing, which means EFT is greater than MFT for when T is greater than 9. You could say that. So you know your regression. So M of 12, you would use your regression to find what M of 12 is. So you would like do this, which is 277.65. Like it can be a lot of different things. That's FRQ2 is like the thing that has the most varying. It can vary the most. So it can be residuals, it can be about appropriateness of a model, all that stuff. Like, is the model appropriate over this range? But they all cover like the same idea. Is it appropriate? And residuals are one way of checking that. You might compare slopes and all that stuff. Okay. Next part C. It says Mr. Pasquale decides he should use model M to make predictions about beyond 12 weeks as long as the difference in predicted maximum bench between model E does not exceed 30 pounds. For how many weeks does he use model M? Give a reason for your answer. What did you guys get for this? 17.3? Yeah, that's it. What was your reasoning? Because that's the answer with the reasons what gets you the point, not just the answer. Yeah, you can have decimals for weeks. If it doesn't tell you to round, don't round. Yeah, that works. Yeah, this would probably be our last FRQ. We didn't go over FRQ 1, so I'll just do like a walkthrough of one FRQ 1. Okay, so the way you would get 17.9 is it says beyond 12 weeks. So we're gonna look at 12 weeks. I'm gonna zoom out for this probably. Hold up. Finish. Some stuff quick. Right there. So from 0 to 20, we see that it's increasing. Yeah, that's how I would do it as well, probably. Just relationship is increasing. Yeah. So you're looking for a difference where it's greater than 0. So we know our like slope is equal to we know, okay, E of t is a equation that looks sort of like this. We know it's m of 9 plus our slope from all the way back then, which was 5714, times t minus 9, right? This is like our equation for E of t. Because that's how we calculate it, right? We started from m of 9 and we did a point slope. Does it make sense how we found this E of t? Yeah, you could do a slider. That's one way of doing it. Okay, so it says E of t, right, is the estimate of Mr. Passflyer's maximum bench press in pounds after week using the average rate of change, right? So we know we're going to use it for after a certain amount of weeks. And we have to use point slope. So we're going to say m of 9, which is our point that we know, which m of 9 was 270, plus 5.714, that's the slope we calculated, minus t minus 9. Yeah, you could also do m2 plus 5.714 t minus 2. You could also do that. So that's E of t. And it says the difference between them should never be greater than, yeah, that's your secant line, exactly. So E of t minus M of t has to always be greater than 30, right? So we're trying to find the value where it's greater than 30 because we want a value less than that. So we're going to look at the difference in y values. So we're going to do E of t minus M of t. I'm going to say that's like equal to f of x. I think that much. Oh, we don't have an M of t. So we're going to say this is equal to M of t all the way back here. M of x. Let's make this x because I used x all the way back there. Why won't this work? Oh, okay. Okay. So I'm gonna change the color. Let's see if this could work. Maybe to showcase this. This did not work in any way I wanted to. Oh, it actually did work. Never mind. If you say E of x is greater than 30, you see it intersects at about 17.288. Because this is your calculation for residual and it has to be greater than 30. You have to say E of x is equal to 270 plus 5.1714 x minus 9. Make sure like your variables match. Without writing the equation. Okay, so the reason you use this is our residual calculation. Remember, this is how we calculate our residual. We're trying to find the residual where it's the difference is not greater than 30. So your reason for your answer would be E of t equals M9 plus RT of 9. And in another line, you would probably say E of t minus M of t is greater than 30, which means t must be greater than 17.288 weeks. So that means it's not appropriate past that, because that means our regression is greater than that. So we're going to say Mr. Brian Passwater, or I'm going to say Mr. Passwater, should use model M for t greater than 17.288 weeks. Because the residual beyond 17.288 weeks is greater than 30 pounds. Or you could say the difference between the expected and predicted models are beyond or is greater than. And this is all you have to say. I would say write the expressions because that's how you found it, that's how you calculated it. So can you explain using that? Okay, we could do M of t minus E of t. We add a slider. I'm gonna have to make this bigger. Yeah, you could use a slider as well. Wait, I don't think that works. Yeah, I'd say use an inequality because I don't think it's actually working the way it's supposed to. Because at that point that we're supposed to have, oh wait, no, never mind. At 17, you have to like make this a lot smaller though. So, like it's somewhere around 17.4. Like somewhere between 17 and 17.4. So you have to go like 17.1, 17.2, 7.29, no, 8, 2. You have to keep just estimating maybe. Yeah, I would say use inequality because then you just have to sit and guess numbers. So like we have to guess all the way to here. But I try to keep it less than 30, so. Okay, and because we did not go over FRQ1, I will just do like a quick walkthrough of how you do FRQ1. So let's take this example, for example. Yeah, FRQ1 isn't that bad. Your first one says g of f of 3, so you would say, you would plug in f of 3, you would get g of 3, you'll plug that into your equation, that's your first answer, show your work. F inverse of 30, we're going to look at where f inverse of 30, that's going to be 12. Finish the first two now. Find all values for where g of x equals 1, plug this into Desmos, make a line that says y equals 1, list all of them, that's your first one done. Determine the end behavior, graph it out in Desmos, find out where it goes when it goes towards negative infinity, and say limit as x approaches negative infinity of g of x is equal to whatever that is. For the next step, it says, is it best modeled by linear, quadratic, exponential, or log? We're going to look at our y first. It's plus 10, plus 10, plus 10, plus 10. Our ratio is plus 3, plus 6. But if you see, it's multiplying actually. So we can say multiply by 2, multiply by 2, multiply by 2, multiply by 2. That follows a log pattern. And you would say, for this, you would say, because the y values increase by equal length input output intervals and the x values are multiplied by a constant proportion, it is a log. Yeah. It's not input this time. You're doing output because it's a log. So, and that's how FRQ1 is. So, that was like a minute or two for this one. For C.I, you would say, as the y value, I'm gonna type it out here, but as the y value, as the x values are proportionally increasing, and the y values are increasing by equal length output intervals, the function is a log. I'm not going to write log. And I'll even show you what they wrote, if I can find what they wrote for this answer. Which one is this? This is C. This is what they wrote. This is what they wrote. This is the exact wording they used on the answer key. So similar to how I wrote it, but and that's all FRQ1 is. So we're gonna go back here now. Is there any questions, final questions, comments, or concerns about the FRQs? Yep, we made it. Tomorrow is Polar, and then we have one last crimp session before the exam. Polar, everyone's favorite subject, right guys? Polar is the best. Yep. Hey, Polar ain't that bad, especially the pre-calc polar. Wait until you get the calc. Polar gets worse. That's the next year problem. It's a BC problem. It's not an AB problem. So it depends on which one you're taking. I'm gonna end the recording.